Okay, signal yn is given. It is convolution of these two signals. And it is given that there is a constant omega c here. Omega c is less than mod omega c is less than pi. The question is to determine a stricter constraint on omega c which ensures that yn is this part. Okay. So which property we can use? And if you look at this question, this is in some standard form. If you, you can see the formula sheet. There is a standard result given. It is sine. The standard result is sine omega c n by pi n. If you consider an aperiodic signal, sine omega c n by pi n, remember this is a discrete time signal. And if you take the discrete time Fourier transform, then it will be okay. Remember, this is a periodic function in omega, and this is one period of that spectrum, xc to the power j omega. Okay, if this is xn, this one. Now, can you tell me what is the Fourier transform of, okay, this part, this one. Now, what about the Fourier transform of this? What is the Fourier transform of sine pi by 4 n by pi n? What is the Fourier transform?
The above signal from minus pi by 4 to pi by 4.
Minus pi by 4, 0, minus pi by 4, this is 1, minus pi by 4, okay, this is pi, minus pi. Now what about this? Sine square pi by 4 by pi, sine whole square pi by 4n. What is the property?
Convolution in Fourier domain.
Convolution in the Fourier domain. What convolution? Is
Periodic.
It is periodic convolution. So tell me, what is the periodic convolution of this too? And remember, this is only one period, minus pi pi. Okay. And this is omega. You have to convolve this. So what is the convolution operation? You have to flip the second signal. Anyway, we are integrating. I am considering that integrating over this period, because the integration is over one period only. That is the difference. Periodic convolution and normal convolution. Flip the second signal, second function. Is it this? Now you have to move this point from, because we need to find, since it is the resulting function is also a periodic function in omega. This is 2 pi periodic function. We need to find the convolution from convolution for one period. That means if you assume that we are finding the convolution in this interval minus pi to pi, then you have to move this point from minus pi to pi. Okay. And when while doing the periodic convolution, you have to be careful. This is pi, and if you consider the complete signal, that spectrum, there is this one, right? And when you shift that, you have to check whether some other portion is also coming into this or not. If you consider only this and doing convolution, sometimes you may get wrong answer. Okay, because when you move this point from here to here, it can happen that some of this part will come here and overlap with this. Okay, so we have to be careful. What about this case? If you move this point from here to here, anyway, this function is non-zero from minus pi by 4 to pi by 4 only. Tell me what is the convolution, periodic convolution of these two?
Increase linearly from minus pi by 4 to 0.
Minus pi by 4.
Minus pi by 2.
It is minus pi by 2. Is it? It increases from minus pi by 2 because when this point reaches, it is not this point reaches pi by 4. This point reaches minus pi by 2, then the overlap starts. Okay. So it increases linearly and then this one. This is what? Pi by 2 minus pi by 2. Is it this? Okay, my drawing is not according to scale. So this is pi minus pi. Is it that? And can you tell me that some other part of this get overlapped with this when we shift it? Will it happen in this case? No.
No, sir.
In this case, it won't happen. But you have to be careful while doing the periodic convolution. Sometimes it can happen. Okay, depending on this signal, this spectrum. Okay. Now tell me what is the anyway. We don't need that. This is one. What is the this value? But
Pi by 2.
Pi by 2.
Yes, sir.
Is it pi by 2? Because in the periodic convolution there is a because this width is pi by 2. So pi by 2 into 1 divided by what? In the periodic convolution, what is the convolution property? It is 1 by 2 pi, that convolution, isn't it? Is it? Is it 1 by 2? What is the value convolution of at this point at 0? It has maximum value, maximum overlap when omega is 0, isn't it? So this width is pi by 2. You have to multiply these two. So you will get a rectangular pulse of width pi by 2. So the area is pi by 2. And there is a scaling factor 1 by, sorry, is it 1? 1 by 4, isn't it? Is it 1 by 4?
Yes, sir.
It is 1 by 4. It is 1 by 4. Sorry. It is 1 by 4. Okay. Now tell me what is the answer? When we multiply these two, because convolution in the time domain means multiplication, this one. And you should get the same signal, this signal. That means this spectrum. Tell me what is the, it is given that omega c less than pi, isn't it? So what is the lower limit?
Pi by 2.
Is it pi by 2? Because if this omega c is greater, when you multiply these two, this is 1. If omega c is greater than pi by, anyway, it is given that it is less than pi. If it is somewhere here, you will get the same spectrum, isn't it? But omega c is less than pi by 2, the answer will be different. Is it? So is this the answer?
Yes, sir.
Determine this minus pi to pi x e to the power j omega this integral. Okay, and you have to use this Fourier transform of sequence DTFT of sequence of a to the power n un. What is the Fourier transform of this? It is given in the formula sheet. It is 1 upon 1 minus a e to the power minus j omega. This is a standard result. Using this result and properties of Fourier transform, you have to find this, evaluate this integral. That is a question. Tell me, what is the inverse Fourier transform of this x of n? You can check the formula sheet.
1 by 2 pi integral over a period x of e की power j omega into e to the power j omega and d omega.
Now, my question is, what is this? Is x of e to the power j omega, isn't it? This one, it is given. What is the corresponding signal xn? Okay, so what you are saying is, if you directly substitute this, will you get the answer easily? It's given that you have to use this Fourier transform pair and then using the properties, isn't it? So first, let's see what is x of n here.
A raised to n plus 3 un plus 2.
It is, if you consider this part, it is a to the power n un, isn't it? If you consider this part, there is a multiplication by a. So a into a to the power n un. Now what is this effect? Effect of this multiplication with e to the power j 2 omega. But what will happen in the time domain? Shifting. So can we say that it is n plus 2 or minus 2? This plus 2, I think. A into, so this is the signal xn, is it?
Yes, sir.
Okay. Using this standard result. Now what about this integral 1 upon 2 pi integral minus pi to pi x e to the power j omega? I am writing it as 1 plus cos 2 omega sorry, isn't it? So can we write it as 1 upon 2 pi integral minus pi to pi x e to the power j omega into, let's say, 1 by 2 plus e to the power j 2 omega minus e to the power minus j 2 omega minus or plus. Is it this? D omega?
Yes, sir.
Now what is x of n? X of n is 1 upon 2 pi integral minus pi to pi x e to the power j omega e to the power j omega into e to the power j omega n d omega. This is the inverse Fourier transform. Now comparing these two, can you tell me how is it related with xn? What is the first part? There are three parts. 1 by 2 plus e to the power j 2 omega by 4. If you consider this first part, multiply x e to the power j omega with 1 by 2 and integrate it. What is that?
x0 by 2.
It is, first part is x0 by 2 plus second part is
x2 by 4.
x2 by 4 and then
x minus 2 by
X
4.
minus 2 by 4.
x minus 2 by 4, isn't it? We already know xn. Tell me what is the answer. What is x0? If you put n equals 0, this is 1. What? What is x0 here? x0 by 2?
A cube u2 by 2.
A cube u2. What is u2?
Unit step function.
No, what is value of that u2?
1 1.
A cube by 2 plus. We put 2 here.
A5 by 4.
A5 by 4 plus. Then if we put minus 2, again this is 1. 1 a by 4. Is it? That is this integral. Okay.
So wouldn't the last term will be a by 4 into u of 0?
Sorry.
Wouldn't the last term be a by 4 into u of 0? Because it's x of minus 2.
X of
Minus
x of minus 2 is what?
2. U of 0 into a.
U of a, you put n equals to minus 2 here. This will be 0. A to the power 0 is 1. This is
Yeah.
into a.
And it will be u of 0 2 now.
U of 0 2.
Then-
What is u0?
Yeah. It may be half.
Maybe half.
Yeah.
What is a discrete time unit? How is it defined?
For n greater than 0, it's 1.
1 for n greater
for-
than or equal to 0. Remember, we are
Okay.
talking about discrete time signal. There is no discontinuity
yeah.
there.
Okay.
Okay.